chemical reaction of alkenes. The type of reaction in alkenes is electrophilic addition due to the presence of carbon-carbon double bond. So these are the 6 addition reactions we will cover today. So the reaction in alkenes is mainly electrophilic addition. This is due to the carbon-carbon double bond, which is a high electron density. So we call it nucleophilic site, and it will tend to react with electrophile. So what happens is, when addition reaction happens, the pi bond of the double bond is broken and 2 single bonds are formed. So only one product will be obtained at the end of the reaction, and the product obtained is saturated organic compound. So the A and B electrophile is added to the carbon-carbon double bond. First, hydrogenation. So based on the name, we know that hydrogen will be added to the carbon-carbon double bond, and in the presence of catalysts such as platinum, palladium, and nickel. So the carbon-carbon double bond will open and become 2 single bonds. So example is propane. So when you add hydrogen gas in the presence of palladium, so the carbon-carbon double bond open up and hydrogen is added. And another example, so you can see 2 hydrogen is added to these 2 carbon to become 2-methyl propane. So we will get one product, and the product given will be saturated organic compound. Second will be halogenation of alkenes in inert solvent. So halogenation means we are adding halogen to the carbon-carbon double bond. So inert solvent is a solvent which is it does not disturb the addition of the halogen, which is not reactive. So when the halogen is added, the carbon-carbon double bond will open up and form 2 single bonds. So our halogen normally used is chlorine and bromine. So the product is vicinal dihalide, means that both the halogen are next to each other. And there are some other examples of inert solvents such as CH2, Cl2, CHCl3, and CCl4. So the carbon-carbon double bond is the reactive site of the alkene. So reaction will always happen at the carbon-carbon double bond where the pi bond open up and then 2 Er is added. So I will get 1,2-dibromocyclohexane. And for this reaction, both the Cl atom is added to the carbon-carbon double bond. So the product will be 2,3-dichlorobutane. So third, we have the halogenation of alkenes in water. So halogenation, we are going to add hydrogen to the carbon-carbon double bond, but now it's in the presence of water. So water actually will disturb the addition of halogen. So when one of the halogen is added to the carbon-carbon double bond, and then another OH from the water will also be added to form halohydrin. So our product will have 1 halogen atom and a hydroxide. So when we add halogen, it will be added to the carbon that has a greater number of hydrogen atoms. So let's look at the example 3-methyl-1-butane. So first I'm going to add the halogen. So this carbon have 2 hydrogen atoms. So my halogen, the Cl, will be added on this carbon, and then the OH will be added to another carbon. So remember, we will add halogen first to the carbon with greater number of H. So halogenation happens in 2 conditions, which is water or inert solvent. So remember, your product will be different when the solution is different. So if for inert solvent, both of my Br will be added to the carbon double bond. So you can get 2 Br at the product. And if in the presence of water, we will add Br to the more hydrogen carbon and OH to the other carbon. Next, Markovnikov's rules. So based on Markovnikov rules, in addition of hydrogen halide to an alkene, we will add the hydrogen atom to the carbon atom of the double bond which has a greater number of hydrogen atoms. So for example, propane. So during the reaction of hydrogen halide, I will add the H to the carbon which have greater number of H, and then the halogen will be added to another carbon. So next, hydration means that H2O is added to the alkene. So the condition must be in the presence of dilute sulfuric acid. And when the H2O is added, we will follow Markovnikov rules, where the H is added to the carbon with greater number of hydrogen atoms. So when water is added, we will get the product which is alcohol. So you get one H and one OH is added to the carbon-carbon double bond. So let's look at the first example, ethane. So both the carbon have a similar number of hydrogen atoms. So you can add H to either of the carbon, and then the OH will go to another carbon. So we will get an alcohol. And B is our 1-butene. So the carbon 1 has more hydrogen atoms. So the H will be added to first carbon and OH will be added to second carbon. And for C, so these carbon are having the same number of hydrogen, so 1H and OH will be added. So next, hydrohalogenation. So means that one hydrogen and one halogen will be added to the alkene. So this one will follow the Markovnikov rules, where hydrogen is added to the carbon with more hydrogen atoms. So the hydrogen halide normally refer to hydrogen bromide and hydrogen chloride. So the double bond open up and one H and one hydrogen is added. So for example, ethane. So the H and Br is added and we will get bromoethane. So next, propane. So hydrogen bromide will be added to the carbon-carbon double bond. So we have to follow the Markovnikov rules, which hydrogen will be added to the carbon with more hydrogen atoms. So this carbon have 2H and this carbon have 1H. So my hydrogen will be added to this carbon and bromine will be added to another carbon. So for cyclohexene, these two carbons are having the same number of hydrogen atoms. So you can add the H to either one of the carbon. So next, hydrogenation, which follow anti-Markovnikov rules. So anti-Markovnikov rules normally only involve the hydrogen bromide, where there is peroxide. So the peroxide used normally is hydrogen peroxide or methyl peroxide. So what happens is the hydrogen atom will be added to the carbon atom with fewer hydrogen atoms. So this is anti-Markovnikov. So for example, propane. So when I add HBr in the presence of hydrogen peroxide, the H will be added to this carbon which have fewer hydrogen atoms, and Br will be added to another carbon. So this is anti-Markovnikov. So anti-Markovnikov is H is added to carbon with fewer hydrogen. So the H will be added here and then Br will be added on this carbon. So anti-Markovnikov, we must have the presence of hydrogen peroxide or methyl peroxide. And then for Markovnikov, our H will be added to the carbon with greater hydrogen atoms. So H will be added on this carbon and Br will be added on the second carbon. So we will get 2 bromopropane. Please click like, share and subscribe if you enjoy watching my video. Thank you.